Hey everybody, it's Miss Miranda, and I'm back to talk to you this week about perimeter. We're going to be using what we've learned in our measurement units to measure the outside of some figures. We're going to be doing perimeter this week and then area next week. These are not new concepts. Perimeter is a third grade vocabulary word. It's a third grade skill that they learned in the past, but we're going to be trying to apply a fourth grade spin to it. We'll be working with writing expressions and number sentences to determine perimeter rather than just counting the outside of the figure or adding up the outside of the figure. We'll also be working backwards to solve some things. So I think mostly in third grade when they worked with perimeter was kind of counting around the outside, counting the sides of a square, squares and square units and things like that. But we're going to be working with a couple terms, and these are both interchangeable. We want students to understand that when we're working with perimeter, we're measuring different dimensions. That could be the length and the width, but that can also be called base and height. So length and width is when I'm usually thinking of something that's flat, like on the page, like on a horizontal plane, how long something is and how wide something is. This could be, a rectangle on a page. It might be a section of a garden in my yard. It might be a patio. Something like that would be length and width. When we're working with base and height, we're usually talking about something going on a vertical plane. So maybe like a wall, if I was going to be wallpapering it or painting it. The base would be basically how long it is. But instead of talking about it as width, we talk about it as height, how high up it comes. So either one of these terms, whether you use width and length or base and height, students should be familiar with those two. All right, so that brings me to perimeter. How do we find the perimeter of this figure here? If I don't have any sides to count like I would have done in third grade, we're going to have to use some math here. Now in third grade, this probably would have been 5 plus 5 plus 3 plus 3. That'll give us a total all the way around the outside. There's nothing wrong with that, but there's some other expressions that are going to be a lot more helpful for us when we get into more complex problems. So 10 and 6 is going to be 16, and these are straight line measurements of centimeters. It's like taking this corner here and connecting from here to here to here to here. All right, now another expression we can look at doing is, instead of thinking about it as multiplication, I have two lengths and two widths. So two of my lengths are going to be 2 times 5. And two of my widths are going to be 2 times 3. So it says the same thing, it's just using multiplication in order to show that. So 2 times 5 is 10, 2 times 3 is 6, add that together and get 16 centimeters. That does show up here on your reference sheet. Remember we looked at this last week when it came to measurement. And here's our formula for perimeter. The students have to understand what all this means. This 2L is 2 lengths plus 2 widths. 2 times the length plus 2 times the width. So that is this expression here. Another one we could do, and this is one I actually prefer, is to add 1 width and 1 length and double that. So take 5 plus 3, and then we're going to do twice as much. So I'm adding my length and my width, and then I'm just going to say, well, if that's half of it, then I also need this other one here and this other one here. 8 times 2 is equal to 16 centimeters also. Okay, so different strategies there. All of those are fine. Even if students want to use addition every time, there's nothing wrong with that. They could get the correct answer, but sometimes they will give them a situation where they show them a figure and they want to know an expression, and sometimes they won't give them that as an answer choice. They might have to use one of these and recognize that this means the same thing as that. A little bit of algebra there. All right, so that is really more of connecting third grade to fourth grade content. Here's how we're going to use it in fourth grade. Now we're going to work backwards to solve. So this time I'm given a perimeter, but I'm not given my lengths. And I have to use my known widths in order to figure out what's missing here. All right, so one strategy is to say, I'm going to use my number sentence here. So if I know 32 is my perimeter, 32 is going to be equal to 2 6s. So 2 times 6 plus 2 times what number? Okay, well that still leaves kind of a lot of guessing and checking. So let's see here. 32 is going to be equal to, this is 12 plus 2 times what number? All right, so what we're going to do is say, if I know 6 plus 6 is 12, I want to take that away from 32. So 32 minus 12 leaves me with 20 left over. Now, a lot of students will be quick to say that their answer here is 20, but that's not correct. both of those together are 20. That's where this is. 2 times some number is going to be 20. So all of this is 20. So 12 plus 20 gives me 32. So 2 times, these are going to have to be 10s. And then I can check that by saying 2 times 6 plus 2 times 10, or 10 plus 6, and then doubled. So 12 and 20 is 32, or 16 times 2 is 32. So the correct answer here is 10 centimeters would be my unknown length. All right, here's another one where we're given a perimeter and not given either one of our dimensions, and we're asked what are possible dimensions. Some students will just start randomly guessing and checking. They might say, well, let's see, if this was, 3. If I made this 3 centimeters, well, this would have to be 3 centimeters over here, right? So 3 plus 3, that's 6. How much is left over? 20 minus 6 is 14. This can't be 14. One of them has to be half of that so that both together can be 14. So this would have to be a 7. And this would have to be a 7 centimeters too. So that's a little bit of guess and check strategy. So one thing we could be would be a 7 centimeter by 3 centimeter rectangle. Instead of guessing and checking, what I like to have them do is getting back to this, the length plus the width, and then twice as much is going to equal my 20. So really what I can do is, instead of trying to just guess and check random amounts, say, well, half of my perimeter is going to be served by 1 length and 1 width. So if my total perimeter is 20, then half of my perimeter is going to be equal to 10 centimeters. So then all I have to do is come up with 2 numbers together that add to make 10. And here's one of them, 7 plus 3 is 10. I could also do a 1 centimeter by 9 centimeter. I could do 2 centimeters by 8 centimeters. I already did the 3 by 7. I could do a 4 centimeter by 6 centimeter, and kind of ran out of room here, and a 5 centimeter by 5 centimeter. So I went through and added all those up. That's 5 plus 5 is 10, and 10 doubled is 20. 1 plus 9 is 10, 10 doubled is 20. 2 plus 8 is 10, 4 plus 6 is 10. Okay, if you don't like it that way, you could do 1 times 2 plus 9 times 2. 2 times 2 plus 8 times 2. Okay, so 2 and 18 gives you 20. 4 and 16 gives you 20, and so on. Again, taking half of the perimeter and coming up with 2 numbers is a lot easier than trying to work backwards and randomly come up with 4 numbers. All right, here's another example. We have a hexagon. This is a 6-sided figure. I'm told my total perimeter is 42 centimeters. How long is each side length going to be? Well, this is a regular hexagon. There's 6 sides. So 6 sides times some number is going to equal to 42 centimeters for my perimeter. Or I can think division, 42 divided by the 6 sides. This is going to be 7 centimeters. So each one of those side lengths is going to be 7 centimeters. All right, and then this is a skill that we're going to be using into next week when we work with area. And this is finding the perimeter of irregular figures. All right, so all we're going to have to do is go around the outside to make sure we get all the outside edges, but we've got some unknown sides here. They haven't told me how long this side is, and they haven't told me how long this side is over here. So we're going to use our understanding of rectangles to help us understand. So when we work with rectangles, we know those opposite sides are the same length. And we're also going to use an understanding of parallel lines and horizontal and vertical. So anything that's unknown that is a vertical side, we're going to use other vertical sides to figure that out. So this is a vertical side. This is a long vertical side. This is also a vertical side, and this is a vertical side. So any lines running in the same direction. So if we take a look at this, this is 5 centimeters. This is 3 centimeters. If I can imagine sort of sliding this over here and making that like one big rectangle, kind of like that. And if I combine these two together, this is 5 and this is 3, then this over here has to be 8 centimeters. Okay, that solves my vertical. Now looking at my horizontal, this is 10 centimeters. This is 6 centimeters. This is the part we don't know. Well, I'm not going to add these two together. This time 10 is my longest side here, so some number and 6 gives me 10. Again, if I could imagine taking that and sliding that up. Okay, putting that there. So I'd have this amount plus 6 equals to 10. Okay, I could also flip that around and do subtraction. 10 minus 6 equals 4 centimeters. Now to find the perimeter, I just have to go around and add all of these up. 10 centimeters plus 8 centimeters plus 4 centimeters plus 5 centimeters plus 6 centimeters plus 3 centimeters. Add all those up. I got 1, 2, 3, 4, 5, 6 sides. 1, 2, 3, 4, 5, 6 numbers added together. So I'm just gonna add what looks easy here. So 18. This and this is 10. So 18, 10. There's another 8. All right, so it gives me 36 centimeters for my perimeter. Now, there is a much easier way to do this. For some reason, 4th grade kids don't like to do this, but if you could imagine taking this and sliding it out, taking that and sliding it down, you create one large rectangle, and you using these largest sides. This is a 10 and this is an 8. 10 plus 8 is 18. 18 doubled is 36. So really you only have to do what the formula we were using on the other side, imagining it as a rectangle rather than the sort of irregular kind of squashed rectangle here. Again, just a way to double check. Most students, for some reason, they just want to add all of them together. They don't like to see, they have a hard time seeing how that's really 4 and 6 is the same as this, and 5 and 3 is the same as that. So I might as well just add this together twice and that together twice. But all right, so that's it for perimeter. Next week we'll take a look at area and see how area and perimeter are related. All right, thanks for watching.